3, 2, 1, start. To proceed with the next topic, we will be talking about different integration procedures, more focus on simple substitution. So recalling, I presume that you have already discussed in the previous meetings the basic integration procedures, basically basic integral. So those are by definition and those are based on formulas. So that's where you go back to your list of integrals or your antiderivatives. So recalling what is integration. So integration is the reverse of differentiation. Right? Am I right? So yes. So this time, what if your function does not have a direct formula or it cannot be integrated using a single formula? So there is no established formula. This is where integration procedures come in. And simple substitution, in some references, it is erroneously called U substitution because of the use of certain variable u, but it is more properly called simple substitution. Alright? So, how do we define simple substitution? We define this as, so the integral, so for indefinite integral, the indefinite integral of f of g of x, g prime x dx is equal to the integral of f of u du, where, so u is equal to g of x. So this variable u here is equal to g of x, which can be found here in the original form of your integral. Alright, so the same rules apply. So if you have an indefinite integral, so don't forget to add c in your final answer. So let's have an example. So for instance, let me use, okay. For instance, we have a function. Let's say we're given this function. So let me write integral of 18x squared times the fourth root of 6x cubed plus 5 dx. And then we have to evaluate. Okay, evaluate the following. Okay, so this will be our example number 1. If we look at the function, we can try to determine which is or which one will be substituted. So which is f, which will be our g of x. Okay. So looking at the form, so it will seem intimidating at first, but we can actually rewrite this as, so the radical, we can write this as a fraction. So the integral of 18x squared times 6x cubed plus 5 to the power of 1/4 dx. Alright, so this is now friendlier to the eyes. Which do you think is convenient to substitute? If we look at the function, so we look, one hint would be looking at their exponent or power. So let's try to set aside first the power, or raising this term to 1/4. We can see we have 6x cubed plus 5. Okay. Now 6x cubed plus 5. If we try to compare the exponent of our variable here, the power is 3. Outside this term, we have another bearing an exponent of 2. So since 3 is greater than 2, let's try to assess. So the next step would be, will differentiating this term equal to the term outside the parenthesis or outside the radical? So again, if we differentiate this term inside, so this term being raised to 1/4, will it be equal to the term outside this one? So that way we can assign u and then we can determine du, which is just the derivative of u. Okay? So if we set u equal to 6x cubed, okay, let me change color so that we can apply here. So let me change color to red. If we set u equal to 6x cubed plus 5, what is the derivative of 6x cubed plus 5? So power rule, that will be 3 times 6, so we have 18. And then 3 minus 1 is 2, so we have 18x squared. Then derivative of a constant is 0. Then don't forget dx. We go back to our integral. Do we have 18x squared dx? The answer is yes, we have. So this one, 18x squared dx. Meaning to say, we can use or we can assign 6x cubed plus 3, 6x cubed plus 5 as our u. So this will be the term that we will be substituting. So simple substitution. Since we already have the exact derivative of our u, we don't have to neutralize. Okay, so later on we'll have an example wherein we'd have to add a neutralizing factor. Okay, so let's continue. Since we already have our u, we already have our du, so let's rewrite the original integral. So this one, so to make it to match it with our definition, okay, so let me go back. So to match this one here, no, f will be f of u du will be the format we will be following once we are able to sort this already. So rearranging rearrange Rene. So this is integral of 6x cubed plus 5 to the 1/4 18x squared dx. Okay, wherein we can see that du, but this is du from here, and this one is u. Okay, so meaning to say, f here represents the whole outside of u, the whole radical, the power it is raised to, so that will depend on the function. Okay, so rewriting, this is the sequence. Okay, so from this point onwards, let us now use this format. So this one, so this will be integral of, so instead of writing 6x cubed plus 5, we now write u. Okay, so let me find asan na tong green. Okay, so let me rewrite this one. So let's have green. So this will be u, and then we have green again, to the 1/4, then red, du. Alright? So, instead of writing the whole terms from here, instead of writing this one and this one, what we did was simply represent them with u and du. Okay? Next. So, next would be to integrate this time. Now, what integral or what will be the integration technique that we will use if we're asked to evaluate the integral of u to the 1/4 du? So we go back to your list of integrals. We can use what rule or what formula? So we have a power here. So we can use somewhat similar to what we did in differentiation. This time we do the reverse. So power formula or power rule. Okay. So lain ng power formula in math. Okay. So let's integrate. So the integral of u to the 1/4 du, that will be u to the 1/4. Diba? We have integral of any, say, x to the n dx. This is equal to x to the n plus 1 over n plus 1 plus c. So this, but since we are still substituting, so our convention here is this is not the final variable yet. We will not add plus c first. Okay, so let's proceed. So we have over, so plus 1 di. So plus 1 over 1/4 plus 1. So what is 1/4 plus 1? So you can rewrite it as 1/4 plus 4 over 4. So that would be 5 over 4. So that will be u to the 5 over 4 all over 5 over 4. We're not yet done. So we write this as 4 over 5 u to the 5 over 4. Sorry, this should be red. Alright, now this is already the integral of u to the 1/4 du. The next thing we will do is to restore what u represents. And going back to our definition, or rather the assigned terms, that is 6x cubed plus 5. So to get our final answer, we're going to replace u with 6x cubed plus 5. So this will be equal to, so let me just write here, restore. This will be 4 over 5 times 6x cubed plus 5 to the power of 5 over 4. Sorry. Technicolored na. 5 over 4 and then since we already restored the original term, we can now add plus c. So this is now our final answer. So we simply assigned, or we simply substitute, simple substitution. So what we did here, so to evaluate this integral, we followed this technique. Okay, wherein we determine which is g of x. We determine the derivative. So in other words, g prime x is represented by du, diba? If you look at here, so g prime x dx is actually du. Okay? So in this technique or in this procedure, this is where you will apply your knowledge partly from differential calculus, which was to differentiate, right? Now, this one is pretty straightforward because du already exists in the original integral. What if there is, or the du is not non-existent, but only a part, or somewhat say a portion of it exists in your original integral? So let's have another example wherein we have to add what we call a neutralizing factor. We have to neutralize your the integral. So another one, so number 2, example number 2. Let me move here, there. So for number 2, what if we're asked to evaluate the integral of x squared times 3 minus 10 x cubed to the 4 dx? You might think, since naaman sa sulod sa parenthesis na x cubed, so kaning x squared sa gawas, so muna silang duhang relate. Well, you are partly correct. So let's try to rearrange the sequence of these. So we can rewrite this as the integral of 3 minus 10 x cubed raised to the power of 4 times x squared dx. Right. Now let's try to use the assumption earlier that our u here will be the one inside this parenthesis. Okay, so let's use that assumption that it will be our u, 3 minus 10 x cubed, and then differentiate to find du. That will be, so 0 minus 10 times 3, we have 30x squared dx. Next question. Do we have complete du? Do we have negative 30x squared dx? Yes or no? Definitely not. But what do we have? We have x squared dx. Diba? Since we have x squared dx, this is where we will try to neutralize, or we add a factor, rather multiply a factor to get negative 30x squared dx. At the same time, neutralize so that it would seem as if we didn't do anything to the original integral. Okay. So proceed. This will be integral of 3 minus 10 x cubed raised to the power of 4. Now we will now multiply. So negative 30. Sorry, di makita. I-judge na ko color theory ani. Sorry, I'm not an architect. So this will be negative 30. So asa nigikan, ma'am? Kita, we're the one who added, or we multiply negative 30 to get du. So we will have to multiply the 2. So x squared dx. And then since we multiplied negative 30 here, we will multiply beside or outside the integral sign, neutralizing factor of negative 1 over 30. Alright? So this neutralizing factor, this one here, this is, let me write something. So this NF here, that is paired with whatever value or whatever we multiply to the right side. So to the right side of the integral sign, we multiply negative 30. To neutralize, this is the reciprocal. The reciprocal of whatever value we multiply to the right side of the integral sign. Why? So that it will as if, or it will be same as multiplying the whole integral by 1. So, nanong dili na lang man idiretso multiply 1, di ba? If you multiply na to ning whole integral by 1, what do we get? So, we go back to the original integral. That's the point. But, we need the value. We need negative 30. So, meaning to say, we have to find the equivalent of 1, which will be multiplied to negative 30. So, find an equivalent. So, pila may atong i-multiply ni negative 30. Okay, so algebra. Okay. So, what will be the value, say x, to multiply to negative 30 so that this will be equal to 1? So, diba, this will be x is equal to, so you simply divide both sides by negative 30. Okay? So, that's how we get this neutralizing factor. Okay? So, just bear in mind, whatever value here, you multiply diri, yung neutralizing factor will be the reciprocal. Alright, so proceed. So, our equation, our integral will now be like this. So, we have to, let's rewrite. We have, let me just stay here, integral of, so we now have negative 1 over 30 times, now, since we already determined what is u, what is du, so let's try to check. Going back again, we have u raised to the power of 4. Do we already have du? Yes, we already have du from here. So this integral, we can now use, or we can now substitute the whole integral with u. Okay, so this will be negative 1 over 30. Let me change the color. So, negative 1 over 30 times the integral of u raised to the power of 4. Raised to the power of 4. Green na lang. Since we represent green with the function, outer function. Raised to the power of 4. And then du. Alright. Now this time, so what will be our next procedure? What will be our technique here? So we simply use what rule? So we have raised to a power, so we can use similar to that of example 1. So this will now be equal to negative 1 over 30. Where is the equal sign? Integral negative 1 over 30 times, so we have u to the 4, integral of u to the 4 du. So that's u to the 5, right? So we have u raised to 5. So 4 plus 1. And then don't forget the denominator. Okay, so that's u to the 5. All over 5. Now, no plus c yet. Okay? Now, next, this will be equal to negative 1 over 30 Okay, but this time, so let's try to restore first. Or regardless, with the restore, pwede unya na pod. Okay, so 30 times 5, 150. Then times u the 5. Sige na lang. Dagan kay colors. Many colors. So this will be u to the 5. Then, or you may write u to the 5 in the numerator. Let's just do that in the final answer. Next, let's restore. So restore, this will be negative 1 over 150. Let me just write, okay, times, what is our original u? So this is 3 minus 10x cubed. 3 minus 10x cubed raised to the power of 5. Don't forget plus c. And then, let's try to check. So this can be in this form, or you may write this in the numerator. This will be negative. So 3 minus 10x cubed raised to the power of 5 all over 150 plus c. So this is our final answer. Either of the two. Now, if we try to reassess, the whole procedure was the same as example number 1, but this time we already made use of your neutralizing factor. Okay, so these are both indefinite. Okay, so indefinite integrals, because we don't have the limits yet, or the boundaries. Alright? So I hope you find the example complementary. So we'll have more examples in the next video.